Dear friends, this is Srinivasan, who is having more than 40 years experience in this construction industry, trying to present you a small presentation on how to calculate the concreting volume in a dog-legged staircases and how many bags of cement is required in 1 cubic meter, etc. This is a civil conclave presentation. Calculation of volume of concreting required for a staircases. Dog-legged staircases. This staircases provides access to the various floors of the building. It consists of series of steps, that is a flight, with the landing at appropriate intervals. Each steps consists of a tread and a riser. Tread is a flat part wherein you are stepping in, and riser is a vertical part between each tread in the staircases. This image will explain you what is meant by a staircases, dog-leg staircases. Components of the staircases. Waist slab. Waist slab refers to a slab of the stair that is inclining from the floor slab to a landing slab. Flight. The series of steps between floor and a landing. Landing. The level of floors between flight. Step. The step consists of a riser and tread. Tread is a flat part wherein you are stepping in. Riser is a vertical, that is up and down part between each tread of the stairway. Finding a volume of staircases of a concrete required has to be calculated based on the various mathematical formulas. The important basics of the calculation. Different shapes have a different formulas of area. The area of a rectangle is equal to length in breadth. Area of a triangle is equal to half into base into height. For clear understanding, we are considering the below example of the dog-legged staircases. Here you can see this is known as a riser, which we are climbing up. This is a tread where you are going to stand up. This is a landing, and this is known as a waist slab. This is a hand railing. Two here in the bottom component and two will be in the top component, will makes you 4 component of the handrails. Each component of the staircase is individually calculated. Waist slab concreting volume. Steps to calculate the concreting volume. Landing area concrete volume. Handrail concrete volume. Now we are going to talk about a waist slab concreting volume. The waist slab is an inclined slab. The length of the waist slab is determined by using the Pythagoras theory. Hypotenuse square is equal to opposite square plus adjacent square. Hypotenuse is equal to root of opposite square plus adjacent square. Hypotenuse is equal to root of 1.5 square, that is the height what I am showing it off, plus 3 square, that is the base, which will make the inclined portion length will be 3.35 meter. Now we are going to talk about waist slab. Waist slab is based on the length and the depth. Length into depth into thickness. See, the length is 3.35 meter, width is here, and depth is 0.15 meter. The volume of concreting required for a waist slab is equal to, the volume of required for a waist slab is equal to area of rectangle into depth. That means length into breadth into depth. The concreting volume for the required for the waist slab is equal to 3.35 by 1.2, that is the 1.2 is the width, into 0.15, that is the thickness, makes you 0.603 cubic meter. Number of waist slab is equal to 2. So total concreting volume of the waist slab in staircase is equal to 2 into 0.603 will makes you 1.2 concreting volume. See, from the below figure, the width of the tread will be 0.3 meter, height of riser will be 0.15, length of the tread is 1.2 meter, number of steps is equal to 20. This is the base, that is 0.300. This is the depth, that is what you call as now width, it's 1.2 meter. Height will be 0.15 meter. Steps of the rise of the triangle. Therefore, the volume of concreting required for each step is equal to area of a triangle into depth. Volume of each step is equal to half into base into height into depth. Volume of concreting of each steps will be half into 0.5 into 0.15 into 0.3 will make you 0.0225. Number of steps is equal to 20. Total volume of concreting required for steps is equal to 20 into 0.2225 is equal to 0.54 m cube. Landing concreting volume. This is what I call the length is 2.5 meter, depth, that is the thickness, is 0.15 meter, breadth is 1.2 meter. This is the landing area. Landing in the shape of the rectangle. Hence, the volume of the concreting will be the landing area of rectangle and a depth, that is length, breadth into depth. 2.5 into 1.2 into 0.15 handrail concreting volume. 0.45 cubic meter. The image will explain you how the length will be 3.35, which has been shown in the earlier image. Height will be 0.800 mm. The depth, that is the thickness, will be 100 mm. Handrail is in the shape of a rectangle. Therefore, the volume of the concreting will be area of rectangle into depth. That is 3.35 into 0.1 into 0.8 will make you 2.268 cubic meter. Number of handrail is 4. So, total concreting volume required of 4 handrails will be 0.268 is equal to into 4 makes you 1.07 cubic meter. Total concreting volume required for construction of the staircases as per the images: waste slab concreting volume plus steps concreting volume plus land concreting volume, landing concreting volume plus handrail concreting volume. So, total volume concrete required for this particular staircase is equal to 1.206 plus 0.54 plus 0.45 plus 1.07 makes you 3.26. Calculation of volume for slab. A slab is in the shape of rectangle. In order to calculate the volume of concreting required for a slab, find out the surface area of the slab and then multiply it with the depth. See, this image will explain you how it is. This is the surface area, that is breadth is, that is a width is 0.5 meter, length is 6 meter. So, 6 into 5, that is the surface area of 30 square meter. The depth will be 0.15 meter. So, the area will be length into breadth into depth, that is 6 into 0.5 into 0.15 is equal to 4.5 cubic meter. Hence, 4.5 cubic meter of concreting is required to build a above slab. Calculation of our volume of the concreting for the column. The column may be in shape, any shape. It may be rectangular, circular or horizontal. See, this is the top surface area, this is the depth, this is the length. See what I mean to say, 6 by 0.6 by 0.4. So, how to do the calculation? The top surface area, that is 0.4 into 0.3 multiplied by 3 meter, that is volume of concreting is equal to 0.6 into 0.4 into 3 will make you 0.72. Calculation volume of concreting required for a footing. To understanding, I am dividing the footing into two components. One is a footing and a column. See, here you can see the images. This is the footing, which is the size of B1 L1. This is size of the columns, that is L2 is equal to 1 meter, breadth 2 is equal to 0.8. It is in a rectangular shape with the following dimension: length 1 meter breadth, 0.8 meter depth and that's 400. The volume of second meter is 1 meter by 0.8 by 0.4, that is 0.32 m cube. Part 2, volume of concreting will be 1.2 into 0.1 is equal to 0.12 cubic meter. So, the total volume of the concreting required for this step footing is equal to 0.32 plus 0.12 is equal to 0.44 m cube. Calculation of the volume for a retaining wall. The calculation of the retaining wall is similar to slab calculation, that is the surface area depth is equal to the area. See, this length is 10 meter, height is 3.5 meter, the thickness is 0.1 meter. So, the concreting of the retaining wall is equal to surface area into depth. How to calculate the cement bags required for 1 cubic meter 10 into 3.5 into in order to calculate how many bags of cement required for a 1 cube, you should know the dry density of the cement. In general, density is equal to mass divided by volume. Dry density of the cement is equal to dry mass by a unit volume. Got confused? Let me clear it off. In general, cement consists of a moisture content. So, mass of the cement includes cement with a moisture content. Dry mass includes cement without a moisture content. Dry density is equal to dry mass divided by unit volume. So, usually 4% moist content present in a cement. Dry density of the cement is 1440 kg per cubic meter. Each bag consists of 50 kg. Number of bags in 1 cubic meter 1440 divided by 50 will make you 29 bags. So, what we required is approximately 29 bags required for a 1 cubic meter. Dear guys, tomorrow I am going to present you a detailed presentation on MEP coordination with architect and structural consultant in detail. It's a vital presentation for every civil engineer should know. It helps them to understand the MEP and execute the project in a neat and clean way. I am going to explain with all the calculation, images, pictures, what is good, what is bad, how to carry out, etc. etc. This presentation is going to be a longer presentation, hence kindly watch till the end and give your comments on it. Thank you for watching this presentation. Kindly subscribe, like and share, which will motivate me for a further good presentation. In case of any queries, do not hesitate to write to me. The response shall be at the earliest. Contact me. You can contact me at civilconclave@gmail.com or at my Telegram group, Ask Srini Telegram group. The link is as follows. Kindly subscribe, like and share so that I get motivated and give you more presentation. Once again I request you kindly share, subscribe and like.